Hello everyone, I am Milind Dahir Rao and today I will explain you about the ACI protocol. So basically what are the protocols in ACI and how these protocols works together to make it an intelligent ACI fabric. So there are the different protocols running inside the ACI fabric. So the first protocol is the ISIS. Yeah. Second protocol is VXLAN. Then third protocol is MPBGP. Fourth is COOP, that is the Council of Oracle Protocol. Fifth one is your OPPlex, and sixth is LLDP and TSCP. So these are the different protocols running inside the ACI fabric. The first is the ISIS, second is VXLAN, third is MPBGP, the fourth is COOP, that is the Council of Oracle Protocol, and fifth one is OPPlex, and sixth is the LLDP and TSCP. Now let's understand about each of the protocol in detail. So the first protocol is ISIS. Let me open a network diagram to explain you about the ISIS protocol. Let me explain you about this network diagram. Very simple network diagram. So we have two spine switches in a redundant mode. We have a multiple leaf switches, leaf 101, leaf 102, 103 and 104, and connected to spine switches in a redundant fashion. I have shown a single epic controller just for the representation purpose, but ideally as per the Cisco recommendation, we will have a three epic plus controllers in working in the cluster mode. So as per the Cisco recommendation, we will have a cluster of a APIC, and in that we will have a three APIC controller. Just understand that for an understanding point of view, I have just shown here a single APIC controller. So the first protocol we have is the ISIS. So ACI is a layer 3 fabric, guys. So the connectivity between the leaf and the spine switches is the layer 3 connectivity, and we are using the ISIS as a routing protocol here. So ISIS is basically your underlay routing protocol which is running inside the between the leaf and the spine switches. So this point to point connection between the leaf and the spine is your layer 3 connection, and we are using the ISIS as a routing protocol. Now obviously you will have a question in terms of why ISIS and not any other protocol. So ISIS is the only protocol who has the option of the customized TLV. Now TLV stands for type length value. Now depending on what you want to advertise, you can use the TLV at the different layer. So ISIS is the only protocol which allows you to have the customized TLV. If you use the ISIS at a layer at a layer 3, then it can carry the IPv4 and the IPv6 layer 3 routes. If you use the ISIS at a layer 2, then it can carry the MAC address information. So that is the reason we use the ISIS as a routing protocol when you have the concept of underlay and overlay. So if you remember, when we use the OTV as a technology, I think that's the out of support from the Cisco. But then in that also we are using the ISIS as a routing. Now the good thing here is we don't have to configure the ISIS manually. So the ISIS gets automatically enabled. So when we register this leaf and the spine switches to the APIC controller, the ISIS gets automatically enabled on the ACI fabric. So that's the good part about the ISIS as a protocol. So on top of the ISIS, the next protocol we have is the VXLAN. So let's understand about the VXLAN, guys. Let me just clear my whiteboard to explain you about the VXLAN protocol. Okay. This is the same diagram. I have just added the couple of endpoints here just for the easier understanding so that I can explain you in a more better manner. So on top of the ISIS, the VXLAN would be getting established. So the VXLAN would be getting established, which means this leaf and the spine switches will be acting like a VXLAN VTAP, right? So what is the VXLAN VTAP, guys? VTAP is the virtual tunnel endpoints, right? So these leaf switches will basically form a tunnel to the corresponding spine switches. So let me just show you. So these leaf switches will form a tunnel to the corresponding spine switches, right? That's how the VXLAN tunnel will be formed. Now, obviously, you will have a question in terms of what is the use of the VXLAN in the ACI fabric? Why do we need the VXLAN here? So let's understand this from an example, guys. Now, say for example, we have a two users. Let me just back to my whiteboard in a proper manner. Yeah, so we have two users, user Bob having the IP address 10.1.1.10 and user Jeff with the IP address 10.1.1.20. So these two users are part of the same network and they want to communicate with each other. Now, how these two users will communicate? Because the ACI is a layer 3 fabric and we need the layer 2 extensions, right, across these leaf switches. Then only these two users will be able to communicate, and that's why the VXLAN helps us here. So VXLAN help us to extend the layer 2 connectivity across the leaf switches by using the VXLAN VTEP tunnel. So that is the advantage of the VXLAN, and that's why we use the VXLAN in the ACI fabric. So for example, this leaf switch is connected to the bob. When the bob wants to communicate with the J, so the leaf switch will add the VXLAN header and it will send the traffic to the J. So that's the advantage of the VXLAN. So VXLAN also has the another advantage of the multi-tenancy, right? So VXLAN has the another advantage of multi-tenancy. So how multi-tenancy will help here, guys? We discussed in the previous videos that in an ACI we can create the multiple tenants. Now say for example we created a tenant called as the tenant X. Say for example for customer X, and that customer using the VLAN 10. We have created the another tenant. So for example tenant Y, that is for the customer Y, and this customer is also using the VLAN 10 in the ACI network. Now, how we will segregate the traffic of VLAN 10 of the two different tenants, that is the tenant X and tenant Y. So that's why the VXLAN helps us here. So VXLAN will add a VNI ID. So for example, VXLAN will add a VNI ID of 10101 to this tenant X VLAN 10, and it will add a VNI ID of 2101 to the tenant Y VLAN 10. So that's why VXLAN will help us here. So that's the advantage of the VXLAN. So first advantage is it helps to us to extend the layer 2 extension, right? So this is actually the second advantage, and the first advantage is the layer 2 extension. The third advantage of VXLAN is the it creates the 16 million L2 segments. So VXLAN helps us to create the 16 billion L2 segments. That's the advantage of the VXLAN here. So basically, all the advantages which we have in the traditional network, that is when we use the VXLAN in the NX OS infrastructure, the same advantages are extended in the ACI network as well. Right? So that's the advantage of the VXLAN. So let me just clear my whiteboard, guys. Just give me a couple of seconds. So the next protocol what we have is the next protocol what we have is the MPBGP. So let me just the next protocol, or the third protocol that's what we discussed was the MPBGP. So what is the use of the MPBGP in ACI, guys? So MPBGP is not used for the endpoint learning. So in a traditional network, when we use the VXLAN on the NXOS switches, the MPBGP basically plays a role of the control plane protocol, and it helps us and it learns the MAC address from the VTAPs, right? So and it learns the MAC address from the VTAP and it advertises as a type 2 routes to the all the VTAPs, and that basically helps to establish the control plane across the VXLAN VTAP. But in ACI, MPBGP is used for the external route redistribution inside the ACI fabric. So let me just open a network diagram to explain this in a more better manner. So this is the MPBGP diagram for the explanation. Now in this diagram, the same diagram, I just replaced the endpoints with some L3 leg connectivity. Also on leaf 101, we have a core switch connected via the L3 connectivity, and via this core switch, say we are say for example, we are learning this subnet 10.5.0.0/16. On leaf 104 as well, we have a layer 3 leg connected. It's connected to a router, and it's connected to a router which is connected to headquarter office. And from this side, we are learning these three subnets: 172.16.11.0/24, 12.0/24, and 13.0/24. So how these subnets will be advertised across the ACI fabrics to the different leaf switches and spine switches. So that is the job of the MPBGP. So a MPBGP is basically used for the external route redistributions inside the ACI fabric. So in the ACI, we are using the IBGP as a protocol, and the spine switches are working as a route reflector. So whenever we receive the route from a leaf switch, so that route will be redistributed inside the ACI fabric. So all the leaf switches in the ACI network will learn about this external network. Similarly, the ACI routes will be advertised to the external or the L3 leg, so that the two-way communication will happen. So that is the role of the MPBGP in ACI, guys, right? So the fourth protocol, what we have is the COOP protocol. Right? Let me just clear my whiteboard to explain about the fourth protocol, which is the COOP protocol. That is basically a Council of Oracle protocol. Right? Let me open a network diagram to explain you about the COOP protocol. So endpoint learning is basically done with the help of a COOP protocol. So the job of the COOP protocol is basically for the endpoint learning. So the leap and the spine switches which we have in the ACI network are basically running the COOP protocol. And so the leap switches and the spine switches we have in the ACI are basically running the COOP protocol. Spine switches has the database known as the proxy station table, and the leap switches has the database known as the local station table and the global station table. So let me write it down here. On the spine switches, we have the COOP database known as the proxy station table, and on the leap switches, we have a database known as the local station table and the global station table. So these two databases will be on the leaf switches. So whenever the endpoint, say for example, the endpoint, this Bob is connected to leaf 101 on the interface 1/10, right? And on leaf 104, the user Jeff is connected on the interface 1/20. So this leaf 101 will make an entry of this Bob in the local station table saying that user Bob is connected with the IP address of 10.1.1.10 and the MAC address of BB is connected on interface 1/10. Whenever and similarly, leaf 104 will make an entry for the user JAP saying that user JAP is connected on interface 1/20. At the same time, this respective leaf switch will advertise that information to the spine switches. So spine switch will add that information in the proxy station table. So basically, the proxy station table will have the information of all the endpoints connected on all the leaf switches, saying that on leaf 101 we have a user Bob is connected on interface 1/10, and on spine we will have the information about the JAP saying that it is connected via the leaf 104. So spine switches will have the information of all the users. Now, for example, Bob wants to communicate with the chip, and we don't have this information on the leaf. So the packet will come to leaf 101, and it will not have the information about the chip. So it will use the spine as a proxy server, and it will send that information to the spine saying that it wants to communicate with the chip. As the spine is aware about the chip, so it will forward that packet to the leaf 104, and that packet will reach to the chip. Now, when the JF will respond, that response packet will come to the leaf 101. Then leaf 101 will make an entry in its global station table saying that user JF is behind the leaf 104, and that's how it will maintain this COOP database. That is the Council of Oracle Protocol database, guys. Right? That's how the communication between the endpoints will work. So basically, guys, up to this point, we discussed about the four protocols, right? So first is your ISIS protocol, second is VXLAN, third is MPBGP, and the fourth one is the your COOP protocol. So let's understand how these four protocols work together, guys, right? So let's use the same example, saying that we have a two spine switches and multiple lab switches, and we have a two endpoints, user Bob and user Jeff, and the Bob wants to communicate with the Jeff, guys. Let's also assume that the loopback IP address of leaf 101 is 1.1.1.101, and the loopback IP address for leaf 104 is 1.1.1.104. Right? So when the Bob wants to communicate with the J, the packet will come to leaf 101, like source IP address will be 10.1.1.10, destination IP will be 10.1.1.20, source MAC will be say BB, that is the MAC address of the Bob, and destination MAC will be say JJ, that is the destination MAC for the J. So ideally this packet will come to leaf 101, right? So this packet will come to the leaf 101. So leaf 101 will encapsulate the packet with the VXLAN header, and in that the outer source IP address, so for example the outer source IP address will be say 1.1.1.101. That's the loopback IP address for leaf 101, and the destination MAC will be, and the destination IP will be 1.1.1.104. So how leaf 101 will route this to the destination IP address? So this routing will happen via the underlay routing protocol, which is the ISIS. So this leaf 101 will encapsulate the packet which is coming from Bob with the VXLAN header, and it will be able to route to the destination using the ISIS. So once the packet reaches to the leaf 104, then this packet will be given to the JIP, and that's how the communication will happen. So using the COOP database, the MAC address exchange will happen, and using the ISIS as a routing underlay as a routing protocol, the two VTEX, or basically the leaf between the leaf, the communication will happen, and each leaf wants to communicate with the endpoints connected on the another leaf, then it will encapsulate the packet with the VXLAN header, and that's how the communication will work, guys. Now let's understand that in the same example, say we have layer 3 router is connected. For example, a router is connected to leaf 104, right? So for example, a router is connected to leaf 104. So let me just connect this router to the leaf 104, and via this router it's connected to internet. We are learning the default route. Now say for example Bob wants to connect to the facebook.com, and the IP address of the Facebook is, just for example, it's 100.1.1.10, right? So how this packet will go via this leaf 104? So using the MPBGP as a protocol, using the redistribution of the external routes, it will redistribute the default route on all the leaf router. So basically in the VXLAN we also uses the concept of the anycast gateway. So when the Bob wants to communicate with the leaf 104, it will assume that the leaf 101 is your gateway. So the packet will come to the leaf 101, and using the default route, it will check that the default route is via leaf 104, and using the default route it will be able to access the internet using the facebook.com. That's how the communication will work, guys. Now the next protocol what we have is the fifth protocol what we have is the OPPlex. OpFlex stands for the OpenFlex. The OpenFlex protocol is basically used for pushing the configuration. Now let's consider this for example. The APIC is connected on leaf 103 and leaf 102, and you want to do some configurations for the leaf 101. So you will be managing this APIC via the out of band management. You will be connecting via the out of band management to this APIC controller, and you will do some configuration. So how this configuration will be pushed to the leaf 101? So that will be done using the OpFlex protocol. So basically the leaf switches and the spine switches which are connected on the APIC controller, these switches will be running the OpFlex agent. So the OpFlex agents are basically going to convert your configuration of REST API into the relevant CLI and then further push that configuration to the relevant switches. And that's how the OpFlex helps us to is basically a management protocol, and it helps us to push the configuration to the relevant agent. So that's the job of the OpFlex protocol, guys. The next protocol what we have is the LLDP and DSCP. So what is the use of LLDP and DSCP in the ACI, guys? So LLDP is used for the discovery of the leap and the spine switches basically, right? So LLDP is basically used for the discovery of your leap and spine switches. And once these devices are discovered, then these devices need the loopback IP addresses to participate in the VXLAN. So these loopback IP addresses is assigned by the APIC controller with the help of the DSCP. So that's how these protocols are works in the ACI fabric, guys. So just for the quick overview, ISIS is basically your underlay routing protocol. The VXLAN is your overlay protocol, and we don't have to configure these two protocols manually. Basically, the ISIS and VXLAN we don't have to configure manually, and it gets automatically enabled as soon as these leap and spine switches are registered on the APIC controller. The next protocol is the MPBGP protocol that is used for the external L3 routing, right? For the external routing redistribution of the external routes in the ACI fabric, we use the MPBGP as a protocol. COOP protocol is used for the endpoint learning, right? With the help of a COOP protocol, we basically learn the endpoints. And OpFlex is the OpenFlex standard protocol, and this is used for pushing the configurations on your leap and the spine switches. That's the job of the OpFlex protocol. LLDP specifically for the fabric discovery, DSCP for assigning the VTAP loopback IP addresses to the leap and the spine switches. So these are the protocols which we are using in the ACI fabric and then their requirement is, guys. So the next video, guys, will be very interesting. We will discuss about the fabric discovery and the registration. So we will discuss about how these devices, the leap and the spine switches, we can register on the APIC controller, guys. So next video will be very interesting, guys. So I highly recommend you guys to like and subscribe to my channel. Thank you.